Today, I'd like to give you a glimpse into the future. Now, I'm not a mystic Meg or a time traveler. Instead, I'm quite the opposite. I'm a scientist. To be precise, I'm a quantum scientist. As such, I don't use a crystal ball or a time machine to see into the future. Instead, I use quantum mechanics. I study the basic building blocks of matter. And through this, I see a new future. A future with alternative technologies that will change all of our worlds completely. And that fascinates me. But more of that a little bit later. I think I should start with a little discussion on the pace of change that we see in our world. It's phenomenal. The changes in society brought about by technology over the last 90 years has been bigger than in the previous 1 million. Stop for a minute to think about that. That's the equivalent of 1 year equating to about 15,000 in each of the last 100 years of time. 1 year equivalent to 15,000. That's a phenomenal rate of change. Analog technology changed my parents' lives with televisions and radios. Digital technology is changing all of our lives with computers, smartphones, and of course the internet. And if we look at just the last 10 years, e-commerce, big data, global communications, and social media, what a phenomenal rate of change. The radio took 38 years to reach 50 million users. The television, 14. The internet, 4. The iPod, 3. And Facebook clocked up 200 million users in its first year. That pace of change is so fast, it's almost instantaneous. But as a quantum physicist, I see a new horizon, a new change, a new series of technologies, and they're based on quantum technologies. So I'm sure some of you are wondering what quantum's all about. Is it quantum of solace? Is it the quantum leap? Well, for the Bond fans, it's nothing to do with that, and the quantum leap's only a little bit closer to the truth. Quantum comes from the Latin word meaning how much, and quantum physics means how much probability. So let's think of a probability as a coin toss. If we flick a coin, it lands in our hands, it's either a head or a tail. But what happens when the coin's spinning? It's up in the air. It's a head, a tail, a head or a tail. We don't know what the outcome's going to be until it lands and hits the deck. Quantum physics is a little bit like the spinning coin. In quantum, things can be different states. They can be two states at the same time, just like a head and a tail. And nothing is certain until the outcome is observed. If we look at this on the tiny scale, we take an atom here with its nucleus right at the center, and we've got all the electrons circulating around that atom. We can't say precisely where an electron is. All we know is, at any particular given moment in time, probably where it will be. So if we think that through, if this nucleus is here in Glasgow, the electron is probably orbiting it somewhere in Glasgow. But as it's all about probabilities, there's a small chance that it's in Okinawa, on the other side of the world, or even in Mars. That's a difficult thing to comprehend, isn't it? But that's what quantum physics tells us. As we look around the auditorium here, we see chairs, walls, people. Everything seems physical. Everything seems real. Everything seems governed by the laws of physics. But when we look at this microscopic level, it's all just probabilities. So all of these things that we take to be real, they're rather than being the laws of physics, they're just very likely probabilities. So this weird understanding of quantum is important because it lets us look at the world in a different way. And once we do that, it lets us start to use quantum physics to invent things. Quantum's got a few tricks up its sleeve. Take this. This example is wave-particle duality. We think of something like an atom to be solid, to be like a ball, but it can also be like a wave. Perhaps a little bit like the ripples when you throw a stone into the water. Imagine you're there, you're throwing a stone into the water, the ripples ripple out. Somebody else comes along and joins you and throws a second stone. The patterns become more complex. They merge, they interfere with each other. The same thing happens at the atomic level. And that lets us now build devices called atom interferometers, where we can take the waves of individual atoms and use them to sense what's happening to an individual atom. We might want to look at its effect of electricity, magnetism, mass. We can use these electrons individually to start and make these measures of our world and our universe. A second strange trick that quantum has up its sleeve is known as entanglement. Einstein called this spooky action at a distance. Two atoms, one here, they become entangled. They behave as an ensemble. So if something happens to this atom, it happens to that atom. Think of our tossing coins as a state. We could have one atom, a head, a tail, a head or a tail. Another, a head, a tail, a head or a tail. We build it up coin by coin. The probabilities and the possibilities grow exponentially. And it's this exponential growth and the entanglement that leads to the ability for us to use atoms as quantum information bits. We can use these atoms as the bits to build future computers. The potential is exponential. The atoms are tiny, and we can drive the entanglement across many, many atoms. So that's probably enough of the science for now. I promised that we'd take a look into the future and a glimpse into the future of what technology might bring. So let's take a look into the not too distant future, and let's take a look at a new Glasgow. Let's call it a quantum Glasgow. So imagine that your gran's not well. She's gone to the hospital. She needs a scan. But instead of getting into an MRI machine with all the claustrophobia, the stress, the noise, the expense, she pulls on a hat. But it's a special hat. It's a quantum hat. It's got millions of pixels that can read the electromagnetic waves inside her brain so that the doctors can see her health, her brain health, and it's all reported real time. A much simpler, more elegant solution. But then maybe this quantum cap could become a thought-collecting cap. What would you use that for? Well, imagine my wife tells me to pick up some Brussels sprouts at the shop. The cap catches my thought. The next day, I'm coming out of the shop, and it reminds me about the Brussels sprouts. Put them in the bag, and I leave the shop, job done, instead of, as normal, with a bottle of wine in a sense that I've forgotten something. The cap can lead on to all different forms of sensing for life sciences in many, many different ways. But meanwhile, back at the hospital, the scientists have fired up their first quantum computer in Glasgow. And that quantum computer is able to make enormous numbers of calculations, millions upon millions upon millions of more calculations than a standard computer. And we're able to model the way that proteins fold. How does DNA work? How do the genes transfer from one generation to another? And now what they're starting to do is they're starting to look at how these genes can create pathways to cure disease, cancers, Parkinson's. So quantum computers would literally change the way that healthcare works in the world. We're out of the hospital now. Granny's gone home. Our quantum hat's got her all safe again. And now what we've done is we moved down into the depths of the Firth of Clyde. And what we're looking at now is a submarine. And this is the first submarine to use quantum positioning. We're using these tiny quantum mechanical forces on our atoms to sense with incredible precision the exact position of the submarine. The precisions that we can create are 1,000 times better than any other technology. And of course, it's all self-contained, so we don't have to go to the surface for GPS. If we can make this technology smaller, we can use it in planes, cars, even in cell phones. At that point, we then have completely autonomous positioning. Safe, simple, reliable positioning. And our submarine is in connection with Glasgow's climate centre. It too has a new quantum computer. The quantum computer is able to measure the weather and model the weather forecast with pinpoint accuracy over pinpoints of time. But not only that, it's able to do more than that. It's able to take in data on pollution, agriculture, human use of land, all these types of parameters, and it can feed those into the computer so that we can learn outcomes to improve our environment, to improve our city, to improve our world. So I hope today I've had the chance to give you a little bit of an insight into this quantum world, to let you think a little bit and use your imagination about how it's going to change our society. To think a bit about how some of the societal changes around health, environment, and safety will change the future of all our lives. It's going to be an exciting time for quantum, a pure quantum leap. Thank you.